will solve quadratics by factoring. A zero is wherever the graph of a function intersects the x-axis, meaning my f of x equals 0, a value for x which f of x equals 0 is the 0 of the function. So if we note in our picture, we have a parabola, and we have two places where our parabola crosses the x-axis. They're located at x equals 1 and x equals 4. We call that zeros. Something else you need to keep in mind, I have this thing called the zero product property. And all it states that if I have two numbers multiplied together, then A equals 0 or B equals 0. So if I have two things multiplied together and I want to set each piece of the product equal to 0, okay? So now we're going to solve an equation by factoring. The first step, we will move everything to one side of the equal sign. So I'm going to subtract the 5x so that we have equals 0 on one side of our equation. So x squared minus 5x plus 6 equals 0. Now I'm going to factor. I should be able to do guess and check because my leading coefficient is a 1x squared. Because I have this plus sign here, right, that plus sign there, that means my signs are going to be the same. So if I look at the 5, it's negative. So I'm looking for factors of 6 that add to give me 5. Because the signs have to be the same, because when I redistribute, a negative times a negative is a positive, and x minus 2 equals 0, and x minus 3 equals 0. So I set each of those pieces equal to 0, and I get x equals 2 and x equals 3. The other clue we have to tell us how many solutions there are, if I look at the exponent in the original problem, note that it's a 2. So that means I should have 2 solutions. In our next, take a second to try the example you tried. Remember, you have to have your quadratic equal to 0, so you have to add 12 to both sides of your equation. Now you can factor. Notice your constant, the plus 12, is a positive sign, so that means my signs are both going to be negative or the same. Because the middle term is negative, my signs will both be negative. Factors of 12 that give me 7 are 3 and 4, and we just place our x. Zero product property says we set each of these expressions equal to 0, and therefore our solutions are x equals 4 and x equals 3. We're going to take a look at a few more examples to make sure we really truly understand what's going on. These are not in your notes, but feel free to add for more reference. Just like before, I want to have my equation equal to 0, so I'm going to subtract 3 on each side. X squared plus 15x plus 56 equals 0. Yeah. 56 is positive, this constant, so that means my signs are going to be the same in my parentheses. Factors of 56 that add to give me the middle 15 are 8 and 7. So now we're able to set each of these expressions equal to 0. So So our solutions are x equals -8 and x equals -7. In this example, note that x squared is on the right side and the 9x and 36 are on the left. Ideally, I would not want to deal with a negative x squared, so I'm going to move the rest of the left side to the right. When we do so, we have 0 equals x squared minus 9x minus 36. This time when we factor, because the sign of the constant is negative, that tells me my signs are going to be different in the parentheses. So one will be positive, one will be negative. Factors of 36 that give me -9, well, remember 36, you have 1 and 36, 2 and 18, 3 and 12, 4 and 9, 6 and 6. So the pair that give me -9 with different signs is +3, -12. Okay, so I just fill in the holes. Now I can set each expression equal to 0 and find my two solutions. X equals -3 and x equals 12. In this next example, note when we move the 8 to the other side, it's like what we did in the first two examples, except now our leading term is no longer 1. So we have to factor by our grouping method unless we are comfortable with guess and check. Okay, so if we take 7 times -8, we have -56. Factors of -56. These include 7 and 8, 2 times 28 is also 56, and 4 times 14 is 56. The pair that give me +26 is here, a -2 and a +28. So remember, I'm going to substitute that in the place of the 26x. 7x squared minus 2x plus 28x minus 8 equals 0. Remember, from here we set up our grouping. The GCF of the first pairing is an x, and what's left inside is 7x minus 2. In the second grouping, the GCF is a 4. What's left inside is 7x minus 2 equals 0. Now remember, now that we have our grouping, the inside of my parentheses need to match in order for this to work. So we take out the 7x minus 2, and what's left is x plus 4. And now I can set each expression equal to 0. So if 7x equals 2, or x equals 2 7s, and x equals -4. The last example, we are only looking at 2 terms. I still want to set things equal to 0. So I want to set my expression equal to 0, keep my x squared term positive if possible. In this type of problem, we're just factoring out an x. That is the only thing both terms in the left side of the equation have in common. And now we can set each of our pieces equal to 0. So note we have x equals 0, 2x equals 3, or x equals 3 over 2. Ta-da! Here's your assignment.